The objective of this lab is to assess different configurations of strain gauges and their relative accuracy for measuring hoop strain. Initially, the full strain gauge bridge is used to measure and analyze the error discrepancy between the theoretical hoop stress and the measured stress. In the second part of the experiment, the strain of the open can is measured and is then used to calculate the pressure in the can. For the procedure for part 1, we set up a new lab file with the following block diagram: DAC assistant, collector with signals, waveform graph, statistics with arithmetic mean and standard deviation, and then numerical outputs for both stats. Then we initialize the pressure of the polycarb tube to be 0 psi, and then we increase the pressure of the polycarb tube in increments of 5 psi. We take the millivoltage readings outputs on the DAC at each of these increments and record them in our Excel file. That is the procedure for part 1. For part 2, the procedure is to keep the same lab view file and block diagram as follows: DAC assistant, collector with signals, a waveform graph, statistics with arithmetic mean and standard deviation, and the numerical outputs for both statistics, but then we add a measure to file block because of the high number of samples being taken. We then sand down the side of the soda can, and then we wire and apply the strain gauge to the soda can, and then we start the measurement, and then open the soda can and let the strain gauge measure data for 1 minute.
For experiment 2, we found that the unopened can had a pressure of about minus 4600 psf, and the open can had a pressure of about minus 500 psf. This gives us a pressure difference of 4100 psf, assuming that opening the can causes it to equalize with ambient pressure. This would give us an open can pressure of about 3600 psf or 25 psi. We calculated the pressure using a similar formula to the one used in part 1. However, because we are using a quarter bridge configuration instead of a full bridge configuration, there is a slight difference. The equation still has E as the Young's modulus, T as the thickness of the can, VR as the voltage ratio, and GF as the gauge factor. The voltage ratio was calculated by dividing the measured output voltage by the input voltage, which was 3.3 volts. Here we see a figure of a quarter bridge configuration compared to the full bridge configuration. And here's the formula that we used for calculating pressure. In conclusion, the purpose of Lab 4 was to assess the accuracy of different configurations of strain gauges in measuring hoop stress. This was done by using a full bridge configuration in part 1 of the experiment and using a quarter bridge configuration in part 2. In part 1, we measured a polycarbonate cylinder with increasing pressure, while in part 2, we measured the pressure difference of an opened soda can. Using the data we collected, we were able to assess the accuracy of the strain gauge by comparing the experimental results against the theoretical values found with the given equations.